Hi, my name is Rena Loving. I am a senior in computer science, and at Mines, I TA for 2 undergraduate courses. I'm involved in ACMW, fraternity and sorority life, Tau Beta Pi, and active Minds at Mines. I'm studying computer science because of the challenge and versatility it offers. I'm welcoming you to the CS at Mines Python video. You learned how to define your own function in the previous video. In this video, we will look at how you can define a function to return a value. But first, let's start with a good quote. If it walks like a duck and it quacks like a duck, then it must be a duck. The point of this quote is that it doesn't matter what type your data is. The only thing that really matters is whether you can do what you want to do with it. More on this shortly. You should be very familiar with the Python input function now. Recall that input returns a string taken from the console. Just like input returns a string, you can return a value in your functions. In the snippet of code shown here, the atom function takes in two numbers, adds those two numbers together, which is stored in result, and then returns the value stored in result. The function itself does not print the value, but if we use a print statement with a call to the function, then the value returned by the function gets printed. In this example, 15 and 12 are added by the atom function. The function returns 27, and then the print function prints the result returned. Unlike some other popular languages, Python uses dynamic typing. Thus, in Python, the variables passed into the function do not need to be predefined. For this example, this slide shows that we can use our atom function to add two strings together. In other words, the atom function can take in two integers or two strings. With dynamic typing, do you think this call to atom will work? No, this code won't work. That is, you are not allowed to add an integer to a string. If you put quotes around the number 5, then it would execute. In that case, you would be adding two strings. We hope you now have a better understanding of what is meant by duck typing. Duck typing is dynamic typing, where type compatibility is determined based on what occurs during runtime. Let's take a look at this next example. What will be printed with this code? We suggest you pause the video, decide what will be printed, and then type your code into Python and check. Were you surprised that nothing was printed? As soon as a return statement is encountered, the function immediately returns and does not continue to execute. Have you ever noticed that Python will return an error when there is no indented line below an if statement or a while loop? The same syntax error will appear if a function is defined without a body. Sometimes, however, you want to define a function without providing all the details for the function. In this case, you can use a function stub, which is basically a placeholder that means to develop later. A function stub will allow your code to execute without this syntax error. Two function stubs are shown on this slide, one of which uses the keyword pass, which means do nothing, and another that uses a print statement. We suggest you again pause this video and practice defining functions. In this case, write a function that takes a list as its parameter, doubles all elements in the list, and then returns the doubled list. For example, if double elements 1, 2, 3, 4 is executed, it should return a list containing 2, 4, 6, 8. As we discussed before, Python uses dynamic typing, which means a function does not need to define the variable type of its parameters or return value. You can, however, define these types if you want to. That is, you can define the variable types with type annotation. Doing so will help ensure your code is using the right types. In this example, the function will only execute if two strings are passed into the function and a string is returned from the function. Otherwise, Python will throw an error. This slide modifies the previous function. Now notice that the input to the function is an integer and a float, and that the output or return of the function is also a float. The return statement will first multiply the two input variables and then return a float. We hope you now have a good understanding of returning values in functions. We encourage you to practice creating your own functions with return statements. Practice both dynamic typing and type annotation to see how the functions behave differently. Just like other Python concepts, the more practice you do, the better understanding you will have. Thanks for tuning in. See you around campus.